Hey, I'm Monty with Deutsche Beverage and Process. Have you been looking to increase the shelf life of any of your beverage products or potentially increase the quality? Or maybe even further protect your equipment from corrosion? If you have a need to remove dissolved oxygen from any of your water sources, whether it be boiler water feeds or specific product water necessities, we have solutions for you that range anywhere from the 10 gallon per minute all the way up to 500 gallon per minute range. In front of us, we have a plug-and-play solution that we want to walk you through and essentially explain how one of these systems work and what are the necessary components that are required to essentially enable it to work. So we're going to start with the most important feature within this system, and that's the 3M, now known as Solventum, fibrous hollow membrane contactor that you pass your water or your product through while simultaneously running a sweep gas in a countercurrent direction. Think of like a shell and tube heat exchanger. And utilizing the laws of partial pressure, remove your oxygen from your water source, or essentially your product source. Inside these contactors is that typically polypropylene fibrous membrane I was speaking about, that the contactor is essentially connected to a water stream as well as a gas stream. And while those two streams are passing each other, we pull vacuum on the system. And again, that's to help with kind of setting the expectations out of the partial pressure. So what we have here, we have a starting liquid connection where essentially you would either pipe up or connect the hose into the front end of our water feed. We feed our water past some pneumatic valves, some flow meters, just to make sure that obviously we're feeding at the correct rate to ensure that this technology works the way that we're desiring. It passes up through the membrane and then kind of loops to a second membrane. These two are running in series. We can have circuits running parallel as well, but again, for the standardized kind of plug-and-play system, which is rated to typically 30 GPM if you're looking to remove dissolved oxygen out to a level of about less than, I'd say about 8 parts per billion. But essentially, you pass your liquid through, and essentially you would connect your outlet pipe and or hose here. On the back side, we have a feed for a sweep gas, which again, you're going to flow countercurrently past your water solution, and essentially a process flow through a rotometer, some automated valves. We have a pressure relief valve that feeds at the same rate through both of these contactors, again, in countercurrent flow to what your water solution's feeding at. We talked about it a little bit, and we'll kind of spin this around and kind of take a look at some of the components in the back, but we're also going to pull vacuum on this system while we're running that process. Let's spin it around and let's look at some of the components on the backside. The vacuum is critical to this application because again, we're trying to adjust the partial pressure within the system. There's a lot of options out in the world for vacuum pumps. What we got in front of us right here is a dry screw technology, which a little more on the luxurious side, but the reality is you don't have to feed it with really any ancillary utilities. We have a lot of liquid ring options that would work as well. They do require a small water feed, but they're very industrial and are simple to use. But as we were talking about, vacuum is basically going to pull on the contactor, pulling from essentially the bottom side of these contactors. And this whole system, as you can really see throughout the system, it is critical to ensure that you have no vacuum leaks because again, we're trying to remove oxygen, so I don't want any air feeding into the system at all. So we use sanitary connections or swage lock tube fittings. We try to completely avoid any threaded related fittings to just ensure that we don't have any breaks in our vacuum process. Our vacuum is controlled by a VFD, and then we can always do this on most all the systems we do. We've got a perfect example here. We go ahead and build our controls directly into the system. With this controls, you have the ability to essentially set up any of the valve configurations to work on any type of recipe processes. Hey, I want to run it this long. I can obviously set both the feed and outlet valve to work together. I can do stops if I'm concerned with temperature or flow, but I have a lot of opportunities to control different components utilizing this panel here. The entire assembly is going to always be built with essentially a sanitary frame, where again, we're looking to serve all the sanitary industries and just ensure that we're not introducing any biological issues into the product, but that we're able to get essentially a nice clean product through. If you have further questions, please give us a call. Again, I'm Monty Pridgeon. This is with Deutsche Beverage and Process. Thank you very much for your time.